Hey everyone, if you're getting ready to tackle your PCI Level I or Level 2 certification exams, you are in exactly the right place. Today, we're diving deep into one of the most critical, and honestly, one of the most tested topics you're going to face, concrete mixing. My whole goal here is to make sure you walk into that exam feeling totally prepared.
So, here's our study plan. First, we'll nail down the core principle of mixing. Then, we'll break down the 3 methods you absolutely have to know. After that, we'll get into the specifics of mixing times. This is pure exam gold, folks. Then we'll cover special conditions, and finally, we'll lock it all in with the key takeaways you need to just ace this part of the test. All right, let's jump right in with the core principle. Before we even touch the numbers and the different methods, you've got to understand the fundamental goal. If you get this, everything else just clicks into place. This is the heart of it all, right here. The whole reason we mix concrete is to get a completely uniform blend. So on your exam, if you see a question about the goal of mixing, your brain should immediately look for 2 key phrases: uniform distribution and uniform appearance. It seems simple, but this is the bedrock of quality control. Okay, this slide lays out a classic exam scenario, comparing what goes wrong when you mess up the mix. On one hand, if you undermix, you get inconsistent concrete, low strength, and those awful surface voids. But, and this is key, overmixing is just as bad. You can literally whip the air out of it, grind down your aggregates, and lose your workability. You gotta remember, both are critical failures.
Now for the methods. This is a huge part of your certification. They're going to expect you to know the difference between these 3 like the back of your hand. So let's get into it. First up, central mixed. And the name really says it all, doesn't it? Everything is mixed completely at a central plant, in a big stationary mixer. Then it's just delivered to the site, ready to go. Think of this as your most controlled, most consistent method. Next is shrink mixed. Now this one's a bit of a hybrid, a 2-step process. It's partially mixed at the plant, which helps shrink the volume, and then the mixing is finished up in the truck on the way over. And finally, we have truck mixed concrete. Just like it sounds, all the magic happens right inside the truck mixer. The truck is the mixer. But, and this is a big but, this method comes with a really important warning that you absolutely need to know for your exam. And here it is. Burn this into your memory. For your exam, you need to know that truck mixing is a big no-no for architectural units. Why? Well, because it just doesn't reliably produce that super high level of uniformity you need for products where appearance is absolutely critical. This is a huge point. Don't forget it. All right, it's time to talk numbers. Pay close attention here. These are the specific, testable details that you, as a certified QC professional, are going to be responsible for knowing and enforcing every single day. Let's break this table down. For those stationary mixers, the rule is 1 minute minimum for the first cubic yard. Then you add 15 seconds for each extra yard. For shrink mixing, you need at least 30 seconds in the plant mixer, then between 50 and 100 revolutions in the truck. And for straight-up truck mixing, the standard is 70 to 100 revolutions at mixing speed. These are your QC checkpoints. You gotta know them cold. Okay, so we've got the standard rules down, but now we're gonna get into the what-if scenarios. Exams absolutely love to test your ability to adapt, and weather is a huge variable. Hot and cold conditions can totally change the game, and you need to know the playbook. The rules for weather are basically a game of opposites. In the cold, your job is all about warmth. You need materials free from ice and snow, and you have to keep the concrete above 50 degrees Fahrenheit. In the heat, you've got to do the exact opposite. You have to cool your ingredients, maybe use flake ice for your water, and keep that concrete below 95 degrees to stop it from setting too fast. Let's really hammer these critical temperatures home. First up, hot weather. Your absolute maximum temperature is 95 degrees Fahrenheit. Anything higher, and you're risking major problems like flash setting. And on the flip side, for cold weather, your minimum is 50 degrees Fahrenheit. This is completely non-negotiable. You need that warmth to make sure you get proper strength gain. And here's one more specific rule for the cold. When you have to heat your aggregates to meet that 50-degree minimum, you can't just crank the heat up indefinitely. You never, ever let them get above 180 degrees Fahrenheit. It's a critical safety check to prevent damaging the mix. Okay, we have covered a lot of ground, so let's boil it all down into your final checklist. Think of this as the absolute must-know info you need to have memorized before you walk into that testing center. Let's run through this one last time. The goal, uniformity. The methods, central, shrink, and truck mixed.
The big limitation? Truck mixing is no good for architectural units. The times? 1 minute for that first yard in a stationary mixer, and 70 to 100 revolutions for a truck mixer. And your magic temperatures? Stay above 50 in the cold and stay below 95 in the heat. That's your list. Memorize it.
So we've covered the standards you need to know to pass your exam. That's great. But getting certified is really just the beginning. The real test happens every single day out on the plant floor. You have the knowledge now, but the real challenge and the real responsibility is applying it. So the question isn't just what you know, it's how will you make sure every single batch is perfect. That's what being PCI certified is all about. Good luck on your exams.